here from West Virginia. All right, hope everybody's doing great. And let's have joke of the day. I need to look for a missing watch, but I can never find the time. Thank you, my son JD, for that background music. Stairway to math. All right, so we're going to stairway ourselves into subtracting polynomials. So we know now how to add polynomials, and when you add polynomials, you combine up like terms. Like terms, remember, have the same variables. Those variables are raised to the same power. So once we recognize that we have like terms, if we're going to combine the like terms, in other words, add polynomials, we're just going to work the coefficients and we're going to retain the variables because that's what's making them alike is the variables. So now let's switch gears into subtracting polynomials. Take a look at the example that I have right here. It says I'm going to take this trinomial. Remember, a trinomial has three terms. Terms are separated by addition and subtraction. So I have a term sitting right here, and I have a term sitting right here, and I have that constant sitting in the back. So there's my three terms making that trinomial. I am going to subtract from that. Take this trinomial, subtract from it this 4 polynomial. It has 4 terms because I've got a term sitting right here. I've got a term sitting right here. And I have a term sitting right here. And there's my constant that's in the back. Terms are separated by addition and subtraction. And remember, sign in front's the sign that goes. That sign is Velcroed to that term. You put your name tag on the front, you never put your name tag on the back. So the sign in front is the sign that goes, that is the name tag for the term. So I'm going to take this trinomial, I'm going to subtract this 4 polynomial from it, and I'm going to combine up those like terms. So what happens here is like saying, well, I'm going to take that m to the third because it's the highest power that I see, and I'm going to subtract this negative 4m to the third. And then I'm going to take, I have no squared terms, but what I'm going to do is I'm going to subtract from nothing this minus 2m squared. So subtract the minus 2m squared. And then I'm going to take this negative 2m that I see right here. Again, the sign in front is the sign that goes. That name tag goes with it. I'm going to subtract from it a positive 4m. And now in the back with these coefficients, I'm going to take that 16 right here and I'm going to subtract a negative 20. So take that 16 and subtract a negative 20. So you guys know that whenever you subtract something, you always add the opposite of the second one. So in other words, if I'm subtracting a negative 4m, that's the same thing as adding a positive 4m. If I'm subtracting a negative 2m squared, that's the same thing as adding a 2m squared. Here, subtracting a 4m is the same thing as adding a negative 4m. And then in the back here, subtracting a negative 20 is really adding a positive 20. And now I'm back to adding up the polynomials. And I'm going to combine up those like terms. And remember, combining up the like terms means I'm going to keep these variables as they are. I'm only working the coefficients. I have 1 of these m to the thirds. I'm going to add 4 more of these m to the thirds. That means I have 5 of these m to the thirds. Now here, if I'm adding 2 of these m squareds to essentially nothing, then that means I've just added in 2 of these m squareds. And then here with these m to the first powers, if I went into the whole 2 of these m's and I went further into the whole 4 of these m's, I just went into the whole 6. In other words, a negative 2 plus a negative 4 is a negative 6. I'm going to work those coefficients using rules of sign numbers that I know, and I'm going to keep what's making them alike. That's the variable. And now here a 16 plus a 20 is going to be a 36. And at this point, none of these are like terms. So I cannot put any of them together, and so this is what I get. Now, that is a long and drawn out way that we can do this. There's some shortcuts that we can take because you know right here that when something sits up against something else, that indicates multiplication. So basically what's happening here is I am taking essentially a negative 1 and I am multiplying it to this entire second polynomial. So if I take a negative 1 here and I multiply it to the entire polynomial, that means I'm going to multiply it here and here and here and here. So when I take a negative 1 and I multiply it to a negative 4, I get a positive 4m to the third. When I take a negative 1 and I multiply it to a negative 2m squared, basically I get a positive 2m squared. When I take a negative 1 and multiply it to a positive 4, I get a negative 4m. And when I take a negative 1 and I multiply it to a negative 20, I get a positive 20. So I can do this long and drawn out method here, or I can distribute that negative. Write that down. Distribute the negative. But here's the key, and I'm writing it in all caps because this is critically important. People mess this up all the time. Distribute the negative all the way through. The second parentheses. Has to go all the way through the second parentheses, because that's what this means. When something sits up against something else, the parentheses is there to indicate that negative 1 is being multiplied to every single term that's in that second parentheses. So like I said, I don't really have to do this long and drawn out method. I could just simply say, I'm going to take this first polynomial, my m to the third minus 2m plus 16. I can distribute that negative through and multiply it, and I'll get a positive 4m to the third, positive 2m squared, negative 4m, positive 20, and now I can combine up those like terms. And I see that I have an m to the third plus 4m to the third, like we said, that's a 5m to the third. I see that I have a positive 2m squared that will not combine with anything, and I see that I have a negative 2m minus a 4m that does combine to be a negative 6m. And then those constants that are in the back, my positive 16 combining up with my positive 20 gives me my positive 36. So yes, the shortcut that you can take is just distribute that negative all the way through the second parentheses. It's got to go all the way through because that's where people mess up. So when you take a look at the second one, I've got my trinomial here, 3 terms, trinomial here, 3 terms, and I'm subtracting this trinomial from that trinomial. So I'm going to take my shortcut and I'm going to take this negative and I'm just going to distribute it through. I'm going to multiply it to each and every term that's in the second polynomial. When I do, it will kick it back into an addition problem, and I will combine up my like terms just like I did when I was adding up polynomials. So my first trinomial is going to stay as it is. But my second trinomial, when I distribute that negative through and I multiply this by a negative 1, I get a negative x squared. When I take this and multiply it by a negative 1, I get a positive 3x to the third. And when I take this and multiply it by a negative 1, I get a negative x to the fourth. So now I'm looking for those like terms. I'm going to start with the highest power that I see, which is my x to the fourth, and I have another one here. So I have one of them, I take out one of them, I have none of them left. Literally none of those x to the fourths are sitting in my pile anymore. They cancel each other out completely. So in descending order would be x to the third, and I don't see any other x to the thirds in there, so I'm going to carry it down, keeping the sign in front. Sign in front is the sign that goes. So it is a positive 3x to the third. And I don't have to show a positive symbol in front. If there's no symbol there, it's understood to be positive. Now after that, going in descending order would be second power. And so I have an 8x squared here. Here's another x to the x squared. So I have 8 of them. I take out one of them. If I have 8 and I take out one, that means I have 7 of them left. Hear those words very carefully. Once again, when I combine up like terms, I retain the variables because that's what's making them alike. I just work coefficients. 8 minus 1 is 7. And then in descending order would be first power, but I don't have any first power x's in there. So then after that will just be my little lone constant here. That negative 1 doesn't combine with anything, so I carry it down. None of these are like terms because like terms have the same variables, those variables to the same power. I don't have that, so I'm done with that one. So this is how we subtract our polynomials if we're in horizontal format. Remember, horizontal means it's going on a horizontal, written out side by side. Let's take a look at what happens when you have your vertical format. Now remember, one of the things people like about vertical format is everything is lined up. You can find your like terms very easily. But we do need to understand that in this problem, we've got our trinomial, 3 terms, subtracting from it another trinomial. So I'm going to take my 2x squared, I'm going to subtract an x squared. So 2x squared minus x squared is just 1x squared. I'm going to take my 3x, I'm going to subtract a 5x. This is where some people start to kind of lose their minds a little bit and they get a little bit confused. So keep in mind that that shortcut was we could take that negative, we could distribute it all the way through that second parenthesis. So that's exactly what I'm going to do. I'm going to distribute that negative here and change this sign, change this to a negative, change this to a positive, and when I do, it kicks it back into an addition problem where I'm just simply going to combine my like terms. So now I'm back to vertical format, adding polynomials. And like I just said, 2x squared plus a negative x squared, 2 plus a negative 1 is a positive 1. Keep the variables because that's what's making them alike. So retain what's making them alike, retain those variables. So a 3 plus a negative 5 will give me a negative 2. So when I have 3 of these x's and I add negative 5 of those x's, I get a negative 2x. And now in the back with these constants, 8 plus 1 will give me a 9. None of these are like terms. None of them, they do have the same variable, but those variables are not to the same power. This is second power, that's first power. There's no variable even here, so I cannot put any of those together. So one more, I'm going to take this trinomial, 3 terms, and this trinomial, I'm going to take this one, I'm going to subtract this one. So again, my shortcut, because I don't want to mess my brain up, I'm going to take that negative, I'm going to distribute it all the way through the second parentheses. When I do, and I multiply the negative here, I get a negative 3x. When I multiply the negative here, I get a positive x. When I multiply the negative here, I get a positive 7. So now when I do that, it kicks it back into an addition problem. Now I'm adding polynomials. I'm going to combine up the like terms. So I have an x to the third, but there are no other x to the thirds because the vertical format has them all lined up. So I'm going to carry my x to the third down. And now I'm going to take my 2x squared. I'm going to take out 3 of those x squareds. So 2 plus a negative 3 is a negative 1. In other words, I just went in the hole one of those x squares. Again, keeping the variables because that's what's making them alike. I'm only going to work coefficients. Now here I have 5 x's. Since I changed it to an addition problem by distributing that negative through the parentheses, 5 x's plus 1x. 5 plus 1 will give me 6. I have 6 of those x's now. And this little 7 guy in the back, he doesn't combine with anything. So I'm going to carry him down with his name tag. Sign in front's a sign that goes. Keep that name tag on the front. None of these are like terms. Yes, they do have the same variable, but they are to different powers. Third power, second power, first power, no variable at all. None of them are like terms. I cannot put any of them together. So this is how you subtract polynomials. Again, hopefully you're seeing that whether it be in vertical format or in horizontal format, the idea is distribute that negative all the way through that second parentheses, because after you do that, you will be back to adding up polynomials and you'll just combine up your like terms. Hope that helps. Have a great day.